In this example, I will use Sulis from Gen 3 to make a heat exchanger. So let's start making a geometry from here. I can create a primitive. I want to make a cylinder, and I can decide how big it has to be. So like 80 by 80, and height I want it to be 160, and I can click create to generate the geometry. Now we have the geometry. We can select it, and here we go to the lattice area where we can decide which type of lattice we want to apply. And I just wanted to use the first one, the surface lattice. I click there, and let's just see how it works using the default parameters. Well, one relevant information here. As you click this button here, you get this resolution. So we're going to use, this is 0.5 millimeters, which is the default resolution. In order to speed up when you make some testing of parameters and things like that, you might want sometimes to increase this value so that the calculation get faster, or sometimes you might want this to be smaller, like 0.3, 0.2, when you want to make the final one to get the precision, get a better precision for the final generation. Okay, let's just see how it comes up by using the default parameters. Here we have cell size and stuff. Let's keep it as it is. Here's the result, and now we might want to change the cell size to make a test to see how it behaves when we get this cell size smaller. And here it is. So every time we make changes, we have to make sure we click generate button so that it will calculate the new variation of our geometry. Now we still have a kind of a regular grid fashion, lattice structure, but say we want a radial structure. So that's easy. We can go to the customize origin button. We click there, and then we have the coordinate type. We can switch to cylindrical. So this will allow us to get the type pattern we want. And then we go back to the settings, and here when we do that, we might really want to switch the absolute size to the cell size, where we can decide how many cells we have in each direction, like radially, vertically, or this direction here. So and let's go with the like 10 by 10 by 10, and let's see what happens. We need to click generate here. And here it is. So now say we want to further change the parameters and make it different. So there's a lot of possibility to customize this result, and mainly they come from the cell sizing. You can decide how many cells in each direction. There's also one interesting option here that we're going to activate, and it's double skin. So this one will allow us to make a heat exchanger that not only allow one single type of liquid to flow through, but two different type of liquids that are going to be they are not going to touch each other. So we just activate this and click generate. And this is the type of result you get with the double skin option. Now let's just set the final values. Of course, in order to reach the perfect settings, you just have to play around with the numbers and try. And here's the settings. So we just click generate last time, and we'll see what we get. So this is the result that I wanted to get. If you, well, this already has a good quality, but if you see here, there might be some more detail. So in that case, if you just want to achieve better detail, you can reduce this value like 0.3, 0.2. And at the end, you can even choose to smooth this using a one of these algorithms. I normally use the last one, and one normally is fine for smoothing, but you can even increase that and smoothing more. As you finish everything, then you might want to export this, and here's the export function. You can export this to a file, and here you just have to give a name, and you will save the file as an STL.